Hi, Mr. Andrew here, and today we're going to work some equations. So this is setting expressions equal to each other. So equations have equal signs. That's what sets them apart from expressions, which don't have them. Now here we have variables. So we have letters that represent numbers that are unknown at this point. We don't know what x is. We don't know what y is. It represents a number, but we have not defined it yet. Now here we have to think, when we do these problems, we have to think of a balance. The pivot point being the equal sign, and on either side we have their expressions. If I introduce, say, a plus 2 here, then I would have to introduce a plus 2 here for them to stay balanced and level. If I divided by 3 here, then I better divide by 3 here to keep them balanced and level. So here, on the first one, x plus 2 equals 10. You can probably solve this in your head naturally without too much thought, but here let's apply a method to it. If I have plus 2 and I want to remove that plus 2 and just have my x equals a number, I need to remove it, and to remove it I subtract 2. I do the opposite of plus 2, which is subtraction of 2. Now since I did this to one side, I have to go on the other side of the equal sign and subtract a 2 here. I get x plus 2 minus 2, those cancel so they're gone, and that equals 10 minus 2, which is 8. And indeed, if I check it back in, if I substitute that 8 in for the x, 8 plus 2 does equal 10. Here on the next one, in front of the variable we have a number. Technically that's called the coefficient. Now here, the implied operation is multiplication. We don't show it anymore, we just imply it if there's a number and a letter and there's no sign between them. So here, we have 9 times y equals 36. I want to remove the 9, but I want to leave the y. So I actually have to do the opposite of multiplication. I have to do division here. If I have 9 divided by 9, that's technically 1, and then the y comes along. Now here, I have to do divide by 9 on this side, the opposite side of the equal sign. 36 divided by 9 is 4. Now while this is technically correct, I would not show this. It's more accurate if I have 1 times y. Well, I don't show the 1. I can say y equals 4. This is the more accurate way, or at least the more formal way of showing that expression, or that equation there. Now x minus 3 equals 8. The opposite of minus 3, well, is plus 3. What I do to one side, I have to do to the other. These cancel. X equals 8 plus 3 is 11. If I do check this back in, I say 11 minus 3 is equal to 8. That is true. So here, 12 times z equals 24. And again, I want to divide that 12 off. And I want to take that 12 and divide it into the 24. Again, opposite sides of the equal sign, they have to be equivalent. So here, I have z equals 24 divided by 12 is 2. Thanks for listening.